Hello guys, welcome back into my YouTube channel. This is second task from the Spark Foundation. So in this task, we are predicting using the unsupervised machine learning, and the first task already completed and uploaded. And if you want to check the first task, I'll give the link in description. And now we are going to complete it. Okay, so first, who have no idea about the difference between supervised and unsupervised? Let me tell you. The supervised machine learning is algorithm trained using the labeled data, and unsupervised machine learning are the trained using unlabeled data. And the supervised it takes directly feedback to check and prediction correct output or not. And the unsupervised learning model does not take any feedback. Okay, so supervised it's a learning model predict the output, and in the unsupervised model finds the hidden patterns in data. Let me give you one of example. Okay, in the supervised machine learning, let's we have a image of a different types of fruits. Okay, in this task, our supervised machine learning to identify the fruit and classify them accordingly. So to identify the image in supervised machine learning, we will give the input data as well as in output for that, which means we will train the model by using the shape, size, color, and the taste of each fruit. And the unsupervised machine learning, it's another machine learning which patterns from the unlabeled input data. I already told you the goal of unsupervised machine learning finds the structures and patterns from the input data and does not need any supervision. Let me give you example. In this, like we will not provide any supervision to the model. In this I mean the same example in the fruit, there we will not give any of the color, taste, and nothing. We will not give, and just provide the input data set to the model and allow the model to find the patterns from the data. And with the help of a suitable algorithm, the model will train itself and divide the fruits into different groups according to the most similar features. Like uh, in the fruits, like banana is like I mean the length and the width, and accordingly it will divide into in the and using the clustering. So in this task, we are going to using the k-mean clustering, and this is the first line importing some basic libraries, that is the from sklearn import dataset. This is library is for the dataset. Now we are going to importing the IS dataset into the datasets. Uh, Actually, there is some of default. I mean, the dataset for your practice, and you can load it and do some tasks. So now we already loaded our data set in the iris variable, and for checking the feature, and this is the line for checking the features of our data set. And now this is the data set in the array form. So now we need to convert it into a data frame. So using the pandas, we converted uh, and see the first five rows using the dot head function. And now we are going to define the target and prediction. Actually, this is the line of code, this is the additional part of this code, and but nothing will affect of your final result if you, I mean, leave it. It doesn't matter. Okay, you just there I want to show you the, I mean, the visualize the data, our the using the sum of using the two columns. Okay, so now this is the look of this using the scatter plot in uh, the data set is visualized. And now the finding the optimum number of clusters using the k-mean classification, and this is our task. First we need to optimum the number of clusters and then represent it visually. So in this line, using the ilog function, we take the data set is in array form, and importing the k-mean and using the WCSS. This is the cluster sum of square. Okay, and in this like this is the elbow method, and using the range function 1 to 11, and we mentioned I mean the number of clusters I, like that is ranging in 1 to 11, and the init, the maximum, and the interior, and the 300, the random state is 0, and now the game is fitted in X and append. So now we are going to plotting the result into a line graph. So this is the elbow method, because the k-mean is actually the WCSS is the sum of square distance between each point, and the centroid is a cluster. So when we plot the WCSS with the k value, the plot looks like an elbow, and the k value corresponding to the point is to optimal k value, or an optimal numbers of cluster. And I already mentioned below, you can clearly see why it is called the elbow method. In this graph, the optimum clusters is where the elbow occurs. This is like a elbow, in the line graph. So this is when the within the cluster sum of square does not decrease significantly with every iteration. And then after this, the next line will be we are going to fit k-mean, and in this line we now we applying the k-mean to the data set, and we are going to the three clusters, and random state is 21. Okay, so now identify the center point of data and evaluation, and then we are going to plot the identified clusters and compare it. So in this code, using the again matplotlib, we have visualized the actual and prediction graph. So we just directly mention the length, width, and font and everything in this matplotlib code, and this is visualization is completed, and our task is also completed, because this is the simple task, and the just we completed both of them. We represented it visually and optimum number of cluster. So hope you like this lecture, and thank you for watching. And if anyone want to check my first task using the supervised machine learning, I'll give the link in description. Please go and watch it. Thank you.